Okay, worksheet 18 relates to some of the things that we talked about yesterday. This is a work problem. One pump can fill a tank with oil in 4 hours, and a second pump can fill the same tank in 3 hours. I guess we'd want to use the second pump then, right? I don't know. But anyway, if both pumps are used at the same time, how long will they take to fill the tank? So how long does it take the first pump to fill the tank? It said 4 hours. Second pump took 3 hours. What's the problem asking us to do? How long will it take? Well, it take to fill the tank if both pumps work together. Okay, so that's what it's asking us to do. So now we're going to, this is just a way to break down a word problem. It's just a little helpful lesson here to break down a word problem. Okay, so planning the solution. If V is the volume of the tank, what expression represents the portion of the tank that each pump can fill in 1 hour? Well, the first pump can do 1/4 of it. The second pump can do 1/3 of the volume. All right, and then it says in 5, what expression, so this is asking for expression, which means it won't have an equal sign. Okay, what expression represents the part of the tank the two pumps can fill in 1 hour if they're used at the same time? Well, we could take 1/4 plus 1/3. Let T be the number of hours. Now we're going to write an equation to find the time it takes for the two pumps to fill one tank. So sort of like yesterday, we can say that it's 1/4 plus 1/3 to fill one whole tank. Sorry, my 3 looks goofy. And you're going to find out how long it's going to take. What would be the time it takes to do that? Okay, so if I multiply the left side by how long, the t value, that would give me t over 4 plus, oh, sorry, am I supposed to do this on number 6? Yes. Okay, no, I just said to write an equation, so I'm going to finish writing it because I would need to simplify that. So t over 4 plus t over 3 would equal the whole job being done. One job. All right, now it says we just wrote the equation, and I think the next one says to solve it, right? Okay, so solve your equation to find how long the pumps will take to fill the tank if both pumps are used at the same time. So t over 4 plus t over 3 equals 1 was our equation. What would we multiply by? The LCD would be 12. Now, there's actually 2 ways for me to show this problem. So if you went on this side, let's say you had done 1/4 plus 1/3, that could have equaled 1 over t. So if you remembered it that way from yesterday, this would be a correct way to solve it as well, and I'll show both of them. Oops, I went the wrong direction. 1/4 plus 1/3 equals 1 over t. Okay, let me show you why these are going to give you the same answer. So some books show them how to do my work problems this way, some show them this way. Okay, what would you, this one we multiply through by 12, and the 4 goes into 12 3 times. So we'd have 3t plus 4t equals 12. If we did the 1/4 plus 1/3 equals 1 over t, then we would have multiplied everything by 12t. Now understanding that we would still get 3t plus 4t equals 12. Okay, so if whatever, you can solve it this way or you can solve it this way. Right. All right, so anyway, what we got is 7t equals 12, and then we divide 12 by 7, and that's about 1.7 hours. Most people don't talk like that and say 1.7 hours. They'll say 1 hour and, what would you do with the 0.7 part to get the minutes? Times what? 0.7 times 60. And that's 42 minutes, isn't it? Okay, so I think that you should be able to convert it if you were asked to. I'm still going to take the 1.7 hours on a test, but I'd like you to know that if you were to recognize, say it was a multiple choice and a standardized test, they're not going to probably write 1.7 hours. They're going to have 1 hour and 42 minutes. Okay, number 8, one delivery driver can complete a route in 6 hours and another driver can complete the same route in 5 hours. Let n be the total number of deliveries on the route. Write an expression to represent the number of deliveries each driver can make in 1 hour. So in 1 hour, then that was part A. We're going to write it down here. Make sure our phones are away. We got 1 hour. The first guy takes 6, so he could only do 1/6. Okay, and you could put times n. All right, and then driver, this would be driver 1. Driver 2, oops, I wrote a B instead of a D. Driver 2 would be 1/5 of n. So part B is asking us to write an expression to represent the number of hours needed to make n deliveries if they work together. So 1/6 n plus 1/5 n. And then part C, we're trying to get them to do the whole one job. So let's just go ahead and put the n's on top. I just like it when it looks like that better. You can understand that 1/5 times n would be n over 5. 1/6 times n would be n over 6. And we're going to do one whole job. That's if they work together to do the job. Okay, the LCD that we would need to use to solve this is saying how many hours will they take. We got to solve it now. Okay, so we're going to multiply through by 30. That's going to give us 5n plus 6n equals 30. So we got 11n equals 30, and we will divide 30 by 11 and get approximately, what's your hours? You guys can write it down. Do you remember, what is it, that one 2.7? Okay, so about 2 hours and 42 minutes. Okay. All right, we're going to go to number 9 on the back. I'm going to set this up in a chart where I have a percent column, an amount column, and then a total column. So I'm just kind of organizing it. You don't have to make the bars for the chart unless you want to. But I'm going to mix how many milliliters of a 0.75% sugar solution. So I'm going to write 0.75 here for my percent. And it says how many of them, so I'll use an X for the amount. And then I multiply that across, and that would be how much sugar is in that particular amount. 0.75 times how much you have would give you how much sugar you have, the total amount of sugar. All right, and then it says how much of that must be added to, so we're going to be adding stuff. We're going to add what comes down here. To 100 milliliters, that's the amount of it, of a 1.5% solution. And we want to form, so this would be 1.5 times 100. And we're going to add that with something else to get, okay, so what we're getting is a 1.25%. What would the amount be that we have? Yeah, but what would the amount column, what would we fill in right here? X plus 100. Follow what I'm saying now? I'm adding that. All right. Okay, so I put x plus 100 there, and then I go 1.25 times x plus 100. That'd be the amount of sugar in that solution in the end. All right, so here's our equation. It comes from right here. Okay, so we get 0.75x plus 1.5 times 100 is 150. I'm going to go ahead and distribute this down here. 1.25x plus 125. Everybody good with what I just wrote? Does anybody have a question about where I got this? All right, then we would finish solving it. You guys know how to solve that stuff. So you would subtract 0.75x from both sides and get 0.50x. And then you would subtract 125 from both sides to get 25 equals 0.50x. And then next you would divide by 0.50 or 0.5. Don't need the O. And that would be 50 milliliters. And they would need to have 50 milliliters of the 0.75% solution. Now, if you needed to know how much solution you do have in all, it would be 150 if you were asked that question. Okay, number 9. We got a soccer player has made 3 of his last 24 shots on goal, or 12.5%. How many more consecutive goals does he need to raise his shot on goal average? He wants to raise it to at least, it says at least 20%. All right, so I'm going to do it like I did the last one. Number of shots will be in my amount this time, and then a total, etc. So I'm going to put in my percentage. He made 12.5%. How many shots did he shoot? That was how many shots did he shoot to get that percentage? 24 shots, which was 12.5%. Now, if you multiply that out, just do 12.5 times 24 here. All right, now I'm going to say, it says how many more consecutive goals. So I need to know how many more shots he needs to do. So I'm going to call that X. But it says he's got to make 20, he's got to make these consecutive goals, one after the other. He's got to make them. So what's the percent? 100. All right, so that'd be 100x. So we got to take his original shot on goal amount plus 100x, and what we want to get is at least 25%. That'd be x plus 24, and this would be 20 times x plus 24. Okay, so here's our equation. These two added together will equal what his goal is to get at least 20%. So what's 12.5 times 24? 300. Okay, plus 100x equals 20x plus 480. Now, why wasn't that 3? Just quick, because I didn't change my percents to decimals, okay? But you understand that actually represents 3 goals. Okay. Now, not that it matters. We can just keep going. I just don't bother changing these because you don't have to, and sometimes it's nice to not have a whole bunch of decimals in the problem. Okay, so we just keep solving. So I'm going to subtract 20x, gives me 80x. I'm going to subtract 300 and get 180. And then I'm going to divide by 80. So 180 divided by 80 is about, or it's not about, it's exactly 2 point, or something like that, right? Is it 2 1/4? Okay, now, can he make 2 1/4 goals? Okay, so what would he need to do? We have to round it up, so he needs to make 3 goals. That's going to be a pretty tough call, isn't it? Meaning, if he got 3 goals out of 24, he needs to get 3 consecutive more to get his shots on goal to raise to at least 20%. Oh, by the way, will it be more than 20%? Or do you understand how it says at least? This isn't going to be exactly 20% if he gets 3 more goals. It's going to be higher. It's actually about 22.5, I think. Okay, number 11. A fountain has 2 drainage valves. With the first valve open, that sounds like one of those work problems again. The fountain drains completely in 4 hours. With only the second valve open, the fountain drains completely in 5.25 hours. How many hours will the fountain take to drain with both valves open? Okay, so we're going to have both valves open this time, so we're going to take, we can do our T over 4 plus T over 5.25 equals 1. Okay, if we multiply through 5, I don't know why I probably should just let you guys do this one. What do you think? What's the 4 times 5.25? 21, right? Okay, so you gotta multiply through by 21. That's going to give you 5.25t plus 4t equals 21. That's 9.25t equals 21. Divide, and you guys can get the answer. You get 2.27 hours. All right, or 2 hours and 0.27 due to 0.27 times 60, 16.2. Let's drop off that 0.2, okay? So about 2 hours and 16 minutes. Okay. 12, you got a pen factory has 2 machines making pens. Okay, together the machines make 1,500 pens during an 8-hour shift. Machine A makes pens at 2.5 times the rate of machine B. So X, let's be the rate of machine B. If that's the case, then 2.5x would be the rate of machine A. Okay. About how many hours would machine A to make the pens by itself? Well, when I did this one, I just said, well, let's just say that together, x plus 2.5x, they made how many pens? Okay, they made 1,500 pens. So let's find out how many pens each machine makes. So that would be 3.5x equals 1,500. Divide by 3.5, and we're going to get decimals, and I'm just going to go with them throughout, even though I know that a part of a pen is not really true. I just don't want to round in the problem right now, so I'm going to just leave it to the decimals. So 1,500 divided by 3.5 was 100. No, oh, I forgot. So 428 point, I think it's 5.7, wasn't it? All right, that's pens. All right, now let's find out how many pens machine A. That's machine B. So do 2.5 times that on your calc. And for A, it makes 1,000, what is it? I know it's over 1,000, let's see. Okay. Now I know that's not going to round right now. I understand your point, though. We're going to get to the end here. Okay, so how long did it take machine A to do that? Or how long did it take for that to happen? Yeah, together they made that 1,500 pens in 8 hours. So I'd like to find out, it says, how many hours would machine A to take to make 1,500 pens by itself? So what could we do? It took it 8 hours to do this. We could find out how many, there's probably more than one way to do this, but I mean, I could do a proportion for this. Okay, I could do 1071.43 is to 8 hours, right? As 1500 is to X hours. At least that would make it some fractions. Or you could have just done what? Divide this by 8 and then take what you got and divide it into 1500, because that's what's going to end up happening. I really wrote sloppy there, so let me write 1500. Okay, so 8 times 1500 divided by 1071.43. Let me see if that gives you the answer I'm expecting. Are you getting 11.2? Okay. So about 11.2 hours, or 11 hours and 12 minutes for A alone. Okay, let's look at 13 and see what you see. This is a super easy error analysis. If you guys remember anything we talked about when we looked at our rational functions, and what was the first step? Look here, and then look at the answers. Go ahead, Hannah. What, honey? Well, what do you know from up here? X. Okay, so what's the error? Okay, they forgot that X can't equal 3. Can't equal -3, excuse me. So the error is not realizing that -3 is not a solution. In this particular case, yeah. I'm just telling you that's what happened on this one. I guess we could have gone through and checked a little harder. 2x times x minus, okay, they multiplied both sides by x minus 3. They got this simplified to here. Looks like they subtracted 2x correctly and added 1 and correctly got it set to 0. And then they factored it and got those two solutions. They factored it correctly. So they did everything correctly. So, wow, I mean, that's not, if a teacher just put a big X on your problem like that, would that tell you much about what you did wrong? No, I would, you know what I would do. I would cross that out, right? And then I would tell you, you should have showed me that it can't be -3. Okay, I'm going to stop there. I just want to show you your quizzes, so I'm going to stop.